Hello guys, so today we're doing chemistry. It's the new topic. It is reactions in aqueous solutions. What we mean by reactions in aqueous solutions is that as we know that there are a lot of type of reactions that take place in chemistry. We have decomposition, synthesis, a lot, many reactions that we have in chemistry. Now, there are certain reactions that can only take place in a solution called aqueous. So to begin with, the terms that are used in this topic. So number one, we have to understand what a solution is. What is a solution? So a solution, it's a homogeneous mixture. We've been using this term, a solution of what? A solution of what? Now, scientifically, what is a solution? So it's a homogeneous mixture. These are the terms that you need to understand. It's homogeneous mixtures of, you can have two or more pure substances. So when we can have two or more pure, not only just substances, but these substances must be pure, right? So we may have two or more of them. Then if it is a homogeneous one, then you have what is called a solution. Now, in other terms, they say a solution, it is a mixture of a solvent and a solute. Okay, take note. A solute plus a solvent is equal to a solution. The example that I can give is that I may have water. So for example, we have water as a solvent plus, let's say, sodium chloride, which is the salt that we normally use, table salt. So when we mix water and the salt, which is sodium chloride, we are going to form what is called a solution. The reason is that water and sodium chloride will combine uniformly, they'll mix uniformly. Like, you can't identify to say this is water and this is sodium chloride, because sodium chloride automatically dissolve in water, which is a solvent, right? So that's the first term that we have to understand. It's what a solution is. So it is a homogeneous mixtures of two or more pure substances, right? So we'll move on to another term that you're going to encounter in this topic, which is called, remember that in a definition of a solution, later I combine to say it is a solvent plus a solute, then we have a solution. So what is a solvent? So a solvent, it is a substance. Okay, so a solvent is the substance in which another substance dissolves. So we have so many examples of solvents, students, where a certain substance will dissolve another. So we have a substance, for example, we know that water mostly is the solvent that we use. Why? Because most of the things, about 90% of the things that we have in the world, or let me say on earth, they will dissolve in water. So a solvent is a substance in which another substance dissolves, right? Then in that definition, they say it is a substance where a solute dissolves. And in this case, to avoid another term in the definition, we just say a substance in which another substance dissolves. That is a solvent. So we have water, petrol, we have so many solvents where other substances can dissolve. Petrol, diesel, ethanol, there's a lot where other substances can dissolve. Now, again, as I said, we introduced what is called a solute. So that's another term that we are going to encounter in this topic. What is a solute? So a solute, we are saying a solute, a substance So a solute is a substance dissolved in another substance. So the one that is dissolving in a solvent, that is what is called a solute. So for example, we have salt ionic compounds, most of them. So ionic compounds are solutes. The reason is that they dissolve and they would decompose into ions. So ionic compounds, for example, sodium chloride, we have sodium sulfate. These, they will dissolve in another substance. Okay, so in general, I'm just saying the substance that it dissolves in another substance. So these are just examples. Sugar is a solute. Now we move on to another term. So the one which is dissolving and the one which is in which that one is dissolving, when you combine them, then we are forming what is called a solution. Now let's define what is aqueous solution. What is an aqueous solution? We've defined what a solution is, of a mixture of a solute and a solvent. So aqueous solution is a type of a solution, right? It's a type. As I said from the beginning, we have a lot of solutions, and one of them is called aqueous solution. So according to the name aqueous is coming from the Latin word which is called aqua. So aqua means water, right? That's one thing to remember. Aqua, anything that has to do with aqueous mean the Latin word it came from was aqua, and aqua in English we mean water, right? So what is an aqueous solution? So aqueous solution is a type of solution where water or H2O, right? Remember, we even talked about how to name these, compounds. The common name for H2O is water. What's a semantic name? Can we remind ourselves? This is what? Dihydrogen monoxide. So, in which a solvent is where water is a solvent. So, whatever solution that you have and that it happens where you are using H2O as your solvent, okay? Meaning, you're using H2O as a substance to dissolve things. So the solutions that you're going to end up will be called aqueous solution because H2O is acting as a solvent. It doesn't matter what solutes you're using. What matters is what solvent are you using. As I said from the beginning, you have a lot of solvents where other substances can dissolve. But when we use H2O or water as our solvent, that mixture that you're going to get at the end of whatever you're doing, an experiment or whatever, is going to be called aqueous solutions. Now, to bring everything for you guys, we are talking about reactions in a solution where H2O is a solvent. So most of the things that we'll be talking about, water is our solvent. We don't care which solute are we using, but all we know is that water will act as a solvent. Now, in biology, you people have learned. Let's talk about the behavior of water. I love teaching this in here so that you people can understand why do we talk about water as a universal solvent. In biology, we say water is a universal solvent, and about 90% of the substances that we have on Earth, they will dissolve in water. Why is it so? So here I want to explain the behavior of water and what makes it to be a universal solvent. Why does about 90% of the things we have here on Earth dissolves in water? Okay, so let's talk about water. So H2O, right? How would you write the bonding in H2O? We are going to have oxygen, then this. Anyway, you learn, you people. I'll teach you actually it's under chemical bonding. Water has what is called a V shape or a bent shape. Okay? So something like this, that's a structure. So why do we say water is a universal solvent? This is the behavior. So water, the key thing you have to remember is that it is a polar substance, so it's a polar molecule. Because of this polarity that it has, it makes almost 90% of the ionic substances or even other things to dissolve in water. So if you say a polar molecule, what is a polar molecule? That makes it, unique, and most of the things will dissolve in it. What do we mean by a polar molecule? So a polar molecule, or a substance that has one end of the nuclear is partially positively charged, and that end is hydrogen. So if you look at water, the ends of hydrogen are what? Are partially positively charged. Then on the oxygen, they are negative. It's partially negatively charged. So because of this, what happens is this. If I introduce, let's say, an ionic substance in water, remember water is a solvent, right? And I've said about most of the ionic substances, they will dissolve in water. Why is it so? Because water is a polar molecule, meaning it has one end which is negatively charged, then to my hydrogens, they are partially positively charged. There's a reason why we get a positive on hydrogen and a negative on oxygen. The reason is that the electronegativity value for oxygen is greater than that of hydrogen. So the one with the higher value of electronegativity gets a negative, then the one with less gets a positive. This means that the bonding, if we talk about the bonding H2O, you're going to find that electrons are not equally shared in here, of which will be another lesson. So now, when I introduce sodium chloride, okay, we know sodium chloride is an ionic substance, which is the common salt, table salt that we use, right? So what will happen is that this sodium chloride is going to undergo the process called dissociation. So you're going to have sodium with a charge. We know sodium has a +1 as a charge, then plus chlorine with a negative charge there. Now, what makes this to dissolve in water is that we can see a sodium with a plus, and we can see hydrogen to water with a negative. So there will be an attraction here, right? Then these macrolines, which is negatively charged, they'll be attracted to these hydrogens, which are positively, partially positively charged. So this makes that almost of the things that we have, which are ionic, normally ionic substances, will dissolve because of its nature. It's a polar molecule. Water is a polar molecule. Not on that, even its shape, its unique shape. I said the shape for water is bent, or it's what? It's a V shape. Sometimes we find something like that. Okay, that's the behavior of water, guys. Now let's move on. We are still talking about the terms that are used in this topic. We understand what aqueous solution is, and I was just trying to make you understand why we talk about water as a universal solvent. Why does most of the things dissolve in water? So, and more especially ionic substances. Okay, so another term that you have to talk about is what is called hydration. Okay, now if we say hydration, this is not a term that you have to talk about from organic chemistry. I say the process of adding water, whatever. Yeah, of course, something similar to that. But in this topic, you're looking at the processing. So hydration, this topic is the process of breaking ions. Remember, we have ionic substances, so we can break those ions, So the process by doing that, that is what is called hydration. Of course, you have to use water. So you're saying the process of breaking the ions of salts. Okay, we know that a salt has a cation and an ion. So the process of breaking the ions of salts to form separate ions. Now, using what? Remember, we are saying aqueous solutions. So using H2O. So we are breaking the salt into its ions, into its separate ions, using what? Water. That's what we're doing. So for example, if I have an ionic substance, let's say calcium chloride, right? Calcium chloride is a salt. Remember, all sorts of chlorides are what? Those things. You have to remember them here. So for example, I have calcium chloride written like this. I can dissociate this one. Okay, can dissociate this one to have calcium 2 plus 2 chlorines here. So me doing this is a salt, then I'm separating it into its ions. I'm doing that's using water, of course. There must be water, right? And this is what is called hydration. Okay, because of the ions, as I've said, because of the ions are going to have that this positive be attracted to the negative of water, then these negatives will be attracted to what? To the positive of the hydrogen. So that is what is called hydration. So just breaking the salt into its separate ions. And guys, remember that when we separate this salt, for example, sodium chloride, the ions becomes free, meaning they're mobile enough and they can conduct electricity. So this is why you find that when salt is like present in water, you're going to find that that water is going to conduct electricity because the ions are free. We have a positive and negative, so anything that we are going to introduce to that water, electricity might be conducted. So another term is called solubility. We have to get this, almost done with this part, then we go to what matters. So what is solubility? So solubility, we say this refers to how much of a substance, will dissolve in a given amount of water. Of a substance will dissolve in a given amount of H2O, which is water, dihydrogen monoxide. So mostly they will say it's grams per 100 milliliter. Okay, which we'll talk about this. It's called concentration, or other, where you have the mass of a certain solute and of volume, which is 100 milliliters. That's volume. So how much that is, is what is called solubility. And substances differs on how they dissolve in the given amount of water. Some they dissolve quickly, some partially, so it differs, right? So it varies greatly. But if they do dissolve, the ions are separated. That's one thing. So when you dissolve an ionic substance in water, what's going to happen? The ions, they are going to what? To separate. And that makes the ions so free to move. And because they can move, what did I say? That solution can conduct what? Electricity. That's what you are saying here. So in my next video, I am going to introduce something that is very amazing. We understand that substances will dissociate into the ions, and for that they can conduct electricity. Now we have what is called electrolytes under this topic. It's also another term, but I will do it separate because it's a lot on its own.